What is up, guys? I'm hoping that you're okay. Got a dead laptop here with me. This is an Asus. I don't know what it is. It's a Vivobook, and it's an i7 11 Gen, 11 or 12, but I think this is 11. Anyways, it's dead. So with the battery, I never tested with the battery, but I know it's not switching on because it came in as dead. So we don't have any life. With the charger, I don't get any response at all on the power supply. It's just stuck on 0. So yeah, let's try to figure out what's happening. When we get the multimeter, and then let's check voltages. Alright, so I've got the multimeter. Let's try and focus on it as well as the motherboard. So I'm going to take the battery off. I don't like working with the battery plugged in or the charger plugged in unless I want to use it. So when we plug an AC adapter over here, okay, what voltages are we gauging? So we're going to look for the main power rail. That's the first thing we're going to look for. So on ground, got 3.61 over there. Let's check here. 3.1. Looks like our main power rail is on 3.1 volts. That's wrong. That is definitely wrong. Let's check for a short just as quickly as we can. We don't have a short on the main power rail. No short, no short, no short, no short. We actually don't have any short circuit. Let me check this side. That's fine, and that's fine. So we don't have any short circuits. This is most likely our 3 and 5 volts. So let's check voltages over there. See what we're getting. Of course we're gonna get 0 because we've got no main power rail. 3.16. So our main power rail is down to 3.16, guys. Something is dropping our main power rail to 3 volts instead of 19. So I'm gonna take the motherboard off, and then we can try to figure out what's happening. So as you know, I'll pause, check off all the screws so that the video doesn't become too long. Alright guys, so I've got what we need from the chassis, and I can see something happened over here. I don't know why, but yeah, definitely something happened. And there wasn't a need for me to take this thing out of the chassis. Yikes. This was covered by the plastic on top of the LCD connector. I thought the 2 MOSFETs are at the bottom. But as you can see, there isn't really a need for us to be at the back. That sucks. Anyways, that heat spot sort of corresponds to these 2 MOSFETs. So let's check them out to see what's happening over there. I'm gonna go into beep mode. Let's see what we're getting. That's fine. That's dead. We've got a dead second MOSFET, so let's deal with that as soon as we can, as quickly as we can, and yeah, move to the next repair. It's a Monday morning, and I didn't really work through the weekend, so yeah, people are gonna be boiling over my head today. And those that left their things on Friday. Okay, so we need this guy off from the motherboard, and we can oh yeah, one of the guys in the comment section asked me, how do you check for a short on a MOSFET? Alright, cool. So a MOSFET typically has got one side that's got, I'm gonna make a video on MOSFETs very soon. One side, it's got, basically looks like it's 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. Same goes with this one. 1, 2, 3, 4, 5, 6, 7, 8. But out of those 8 pins, 4 of them are connected together, they are 1 pin. 4 of them are connected together, they are 1 pin. 3 of them are connected together, they are 1 pin. 3 of them are connected together, they are 1 pin. And then only 1 and another 1. So that makes it a total of actually 3 pins. Oh wow. I hate it when this guy can't focus. Alright, so this is a closer view. As you can see, got these 1, 2, 3 pins, they are connected together, and then that one is on its own. Same goes with that side, those 4 are connected together. 1, 2, 3 connected together, 1 on its own, and 4 are connected together. So basically it's a transistor. Got your source, drain, and gate. Source, drain, and gate. That's all. So when you're measuring for a short circuit, you just measure. So what I'll do is my probe can't sit there, so I can just make it go there because it's the same as putting it here. So when you do this, you don't want to hear buzz when you go across like this. It shouldn't be buzzing like that. Same goes when you do this, it shouldn't be buzzing, and it's not, which is fine, but it's already buzzing here, so this is dead. Or if you put it like this, it shouldn't buzz. So same goes with this one. We do this, it is not buzzing because it's fine. If we do this, it's not buzzing because it's fine. So the same goes with if I do this, it's not buzzing. So that is a dead MOSFET. Let's take it off from the motherboard and replace it with another one. Alright, there we go. So you will see that after that MOSFET has been taken off from the motherboard, when we do this, we are no longer getting a buzz. We are fine. You see? So that's a sign of a dead MOSFET. Most of the time, if you get a dead laptop actually, which is not charging but works on the battery, 90% of the time you get a dead second MOSFET. Yeah. So most of the new technicians, those that are still venturing into the business, they know about replacing the second MOSFET. So let's go and check this one. As you can hear, there's no buzz on this one. It's not buzzing at all. So what you do is, before you replace, you look at the orientation. So as you can see, my 4 pins are on the output, my 3 pins are on the input. So you get a scenario where they are flipped around, and then your 4 pins are on the input and your 3 pins are on the output, or whatever. As long as if the orientation is not the same as the one that you're working on, chances are high that MOSFET is a different type of a MOSFET. You get an N-type, N channel and a P channel MOSFET. So if you put a P channel on an N channel circuit, it won't work. So you end up chasing your tail all around, because you know your MOSFET is fine, but it's not, the laptop is still not switching on. That's because you're using a wrong MOSFET. Very funny. Use my airflow there, and you can bring this guy over like that. Just press it down with the tweezer, and there we go. We are good to work. Right, so now when we plug a charger to this, or an AC power supply, a DC power supply, what do we get? Now we've got response. So we've got response, as you can see on the power supply there. Now we're drawing 0.68, 0.69, 0.8. So this is now working. This is on, guys. Let's plug it. Let's connect it to the chassis and test for display. And you know what the other thing that I'll check is, it'll be if it's charging. Because again, if the MOSFET that I use is the wrong MOSFET, it might switch it on, but it will not charge. So you always want to check that before you close the laptop. So like I said, I actually didn't have to take this motherboard from the chassis. I could have simply worked and finished without opening and closing this, well, without removing this motherboard from the case. Okay, I don't think I need speakers for testing, but I'll just put them in so that I close this thing once and for all, you know, with the battery and everything. Alright, also the connector is in. I don't know if this is a touch or if this is for touch or if it's for the camera. Anyways, let's fire this thing up and see. Okay, 900 milliamps, 1 amp, 1.1, 800, 700. Now it's dropping. There we go. We have picture. Asus 11 Gen Core 7. So yeah, right, it's an 11 Gen. Anyways, guys, this is fixed. The only thing that I'll do now is put a battery on it and we see if it's charging. So we've got a battery on it, 0%. Yeah, and it's charging. It's drawing now almost 2 amps on the power supply. And that's it, guys. Thanks for watching. I hope you learned something. I will see you in another video.